You scroll through social media and see it, a flawless 30-second video of an AI agent at work. It seamlessly researches a competitor, writes a script to scrape a website, and books a multi-leg flight without hesitation. In software development, this is the happy path. It represents the specific outlier scenario where no errors occur. The user types the exact expected commands, and every piece of ingested data is formatted without a single stray comma. The reality of production is messy. Real users make typos, ask off-topic questions, and attempt to jailbreak the system by tricking it into breaking its own rules. These viral demos showcase the empty dining room. They hide the chaotic, expensive production kitchen required to actually serve real, unpredictable customers. To understand why that kitchen is necessary, we have to look at the engine. AI models function as probabilistic calculators, not fixed databases. Every word is a roll of complex mathematical dice. Because of this probabilistic drift, an AI rarely produces the exact same output twice. If it misclassifies a lead 10% of the time, that error cascades, triggering the wrong email draft and poisoning multiple corporate systems. These models are also stateless. They wake up with total amnesia with every single prompt. The interface has to secretly package up your entire chat history and resend it every time just to provide the model with context. This creates the central tension of AI engineering. Developers have a 3,000 millisecond latency budget to force an unpredictable amnesiac algorithm to behave like reliable enterprise software. Start the clock. Your prompt arrives at the context window, the AI's physical disk space. It is tempting to dump your company's entire database onto this disk, but a larger context window requires the AI to mathematically evaluate every single token against every other token. This creates the needle in a haystack problem. Excessive data overwhelms the model's attention mechanism and spikes latency from 1 second to 30. In commercial software, a 30-second wait is a broken product. Simply expanding the disk space doesn't solve factual accuracy. You need a structured retrieval system to find the needle before the model gets lost in the noise. We are 500 milliseconds in. If you ask a standard AI a factual question, it takes a closed-book test. It relies only on what it memorized during a training run that may have finished years ago. Look at Jupiter. If you ask an outdated model which planet has the most moons, it will confidently guess Jupiter with 88 moons, because that was the accepted fact at the time of its training. Retrieval-Augmented Generation, or RAG, turns this into an open book test. It intercepts your prompt to fetch live external data before the AI even sees the question. By retrieving the latest NASA data, the system places the correct information on the desk. While the AI reads the document and identifies Saturn as the record holder with 146 moons, vector database mapping utilizes coordinate geometry. Massive documents are split into chunks, their semantic meaning translated into precise coordinates within a 3D grid. The system finds chunks closest to your question's coordinate, grabbing those specific nearest neighbors and dropping them on the AI's desk. Precise mathematical geometry and strict chunking strategies are the actual backbone of enterprise AI, not the language model itself. At 1,500 milliseconds, the main model has its data, but before it can respond, it must pass through a gauntlet of secondary specialized models. An input routing model acts as a security checkpoint. It scans the prompt for injection attacks, ensuring the user isn't trying to trick the system into leaking internal instructions. After the response is SOI-rated, an output guardrail model performs a final check. It scans the text for data leaks or harmful content before the user ever sees it. Achieving a 99.9% success rate requires this orchestrated multi-agent kitchen operating at fiber optic speeds. The timer stops at exactly 3,000 milliseconds. The user finally sees a pristine, perfectly formatted answer. You can now evaluate AI software by looking past the video. Ask about their fallback logic, their chunking strategy, and the latency of their guardrails. Much of the industry assumes the future belongs to giant all-in-one models, attempting to hold the entire world's knowledge on a single desk. But the kitchen architecture we just explored suggests a different path. As models grow, they become slower and more expensive. Splitting tasks between specialized assistants, one for retrieval, one for security, one for drafting, is the only way to stay within that 3-second budget. Real-world production proves that reliability comes from the coordination of these specialized agents, not the scale of a single model. The future of the technology relies on this synchronized, decentralized swarm.